Andre Castellanos with Snyder Electric, manufacturer technician for this unit. You guys are looking at a Galaxy GPS UPS. This UPS is rated for 20 kW. That's important that you guys are running lighting loads accordingly. So this UPS will keep everything up and running while you guys are under small power instabilities, and it'll also help protect under surges and overload and stuff like that on the output. We have a couple things that we are going to address as far as this system is a little bit imbalanced. So L2 is showing that it's roughly about 18 amps, and that's giving the UPS a 76% load. Right now, once we can balance that out, the system is rated according to its highest load, not a total conglomeration of all the loading. So that's why we're showing 76%. Once we bring that into spec and we balance everything out between L1, L2, and L3, you're going to see the loading's going to go down. Also with that, the battery runtime is going to go up. So it'll actually show you a better analytic of what you actually have. Beyond that, the way we start out, we have this panel cover is going to be what's going to show. That'll be what you'll see anytime you walk up to the unit. The display actually will time out and it'll go to a black screen with Snyder Electric kind of floating around as a screensaver. When you walk up to the unit, you just press on the display and that'll actually start it up, and you'll be able to grab the first page. First page is always going to tell you the output analytics and your battery analytics. Those are the two things you're most concerned with. You want to know how much battery runtime you have, and you want to know how much output load you're putting out. So that's what we put on the front home screen. Within that, it also gives you UPS mode and system mode. So with that, it's going to let you know whether the system's in a wraparound bypass. You have a maintenance bypass panel here. You have the UPS battery cabinet. So if the system's in a wraparound bypass, you're going to see it here in the UPS mode. It'll actually let you know what your status is. Anything other than green is going to mean amber. You're in a situation where you still have output power, but when you get to anything red, it means there's either a fault or there's no output power or something's going bad. So the green, amber, red, those are your key defining points. When you walk up to it, because we have that 18 amp load, we're showing that we're in a really bad imbalance. So it's giving us a orange or yellow exclamation point. When it's in normal operation and everything's perfect, it'll be a green check mark. If something's wrong, it'll give you a red X. With that, when you press it, when it has a green check mark, it won't do anything. It'll just be kind of mute because there's no alarms. Because we have an exclamation, which is a warning, we can touch on that, and we can see that the load is above the UPS warning level. Not that it's overloaded, but there's certain levels that you can put in there that you want to know you're going to get an alarm when it's overloaded. Okay? So once we get that taken care of and balance out the circuit, that'll be clear. You'll have a green check, so it won't do anything. If it's red X, it'll give you all the faults within the system. Okay? So the layout of the UPS, I'm kind of jumping around a little bit. I should have laid you out first. So you guys have maintenance bypass panel. Okay? Maintenance bypass panel is a way to take the whole UPS out of the scenario and to be able to feed your load in the event that you just want utility going out and UPS is under maintenance, UPS is either having problems and unable to support the load. You can pretty much come over, energize your system.
So, excuse me.
Yes, sir.
Right now, you're telling me that this unit's supplying the load?
Correct. Currently, we are supplying the load right now.
Okay. In normal operation, I thought our normal power would be doing battery power.
No. So this is a double conversion online UPS. So this is the schematic for the UPS. What's actually taking place? We have input power, which is the utility.
Mm-hmm.
We have a rectifier, which is taking AC power and turning it to DC power.
Mm-hmm.
Okay, that is keeping this DC bus up and running, whether it be charging the batteries or whether the batteries are supplying the power on the output. Okay, so that DC bus will always stay energized. So if we lose our input, the batteries can effectively feed without any noticeable lost, sag, swell, or anything on the output. That's kind of how we work it to where it's always protected. Okay? So when we have it at DC, we have our inverter, which is taking it from DC back to AC. Okay, that's giving us clean, conditioned power, and it's its own logical sine wave, which is giving a pure sine wave out to all of your equipment. Okay? If we were to put it into a bypass state, we can actually do two ways. You have an internal bypass, which will run through your static switch. We'll basically take your utility and put utility right back out. Okay? That's a point where we transfer the load back and forth. Okay? Then you have your full wraparound bypass. This maintenance bypass breaker is this center maintenance bypass breaker here. So that's to where you can just wrap around the whole UPS. You can shut the UPS down and do whatever maintenance or services or anything in that manner. So that's kind of, so you're always running DC, you're always charging batteries, and at any time, if you lose input, your batteries are going to supply the load. So it's never, you can, if power consumption is an issue, we have what's called eco mode, okay? Eco mode will basically keep this DC bus up and ready, and will be running on the static switch at all times, okay? Which means that you won't really necessarily be 100% conditioned, but you'll have the battery backup. So if you feel that the site's utility is generally good, you don't have very many sags and swells, you guys aren't losing pieces of equipment, you can run it in that eco mode, and that eco mode will still maintain your output power, and it's more energy efficient. So you can run it in the method that you were talking about, yes.
So if we wanted to go to the bypass, what would be the way of doing it?
So
Do you have to open up something and then close that switch?
So what's really good about this system, depending on what you want to do, let's come back to the display, we'll talk a little bit about everything we have. Home screen, everything will come back to this home. You have the single line, which I just showed you, which gives you the flow of power. Then you also have the 3 bars. The 3 bars are where you can actually get into controlling the system. You can find information about the system. You can reset analytics for the system. It's a little bit of everything can be done at that point. So what we have is your status. This will check you on input, output, bypass, battery, and temperature. So if we wanted to check to see how our batteries look, right now we know that we have 9 kilowatts of power charging the batteries right now. It's a small amount. They just got started today, so it'll be about 72 hours before DC has a full charge. It may show 90% towards the end of the day, and then that last little bit will trickle over the next 72 hours. But if you look, you can see we're technically 4% charged currently as we sit. We have 13 minutes of runtime. So with the current load, with the battery state of charge, you'll get 13 minutes of runtime. As the batteries charge up, and as we balance that load out a little bit, we'll see the runtime will go through the roof, you know. So in theory, you can always check to see what you're looking like. Status is operational, which means batteries are good, everything's working. Charger, we are float charging. If it says off, then you know something's wrong with the charger. If you get to a low DC point and the batteries don't immediately charge back up, there's a point that it'll drop below charge, and we can't actually get the unit to come back online until the batteries are either externally charged or replaced, because normally they've hit a low DC for a good amount of time.
How long does it take before your batteries need to be replaced?
5 years.
5 years?
Yes, sir. So every 5 years, what I always try to tell anyone is year 4, start budgeting, right? That way you know by year 5 you'll be able to drop it in and be no problem. The batteries, I normally don't set up self-testing because it's just like a loaf of bread, right? If I come and I self-test every 14 days, I'm taking 10% capacity every 14 days. I'm never going to get those slices of bread back, right? I'm going to lose them, and then when I get to my 5-year mark, I might be where I've already depleted the batteries too many times. So they might be on the low side at that point. But with that, we do yearly maintenance services. We have contracts that will include parts, labor, a little bit of anything. I highly recommend that. It's a tough situation when a power module fails or a piece fails, and we're looking to try to find $12,000 tomorrow, right? That's when we have that warranty in place. We come out, we fix it, we do everything, and we're gone, and you guys don't have to worry about where you're coming up with any extra budget. So,
What do you check on your annual maintenance, what all you changes on it?
so annual maintenance is what we do is we come in, we verify the functionality of the system. So we basically will take it to, we'll tie in with our tuner. So I have a computer tuner that helps me to identify everything with the system. Logs, waveforms, you name it, I can see it. So I come in, I verify what my system's done over the years. I look, see if, do I have 75 transfers to battery, you know, because that's going to tell me we need to start looking at why we're transferring the battery so often, what's happening to the system, because you should have maybe 5 to 10 a year, right? You should, and then are they short duration or are they long duration? You know, are you experiencing sag, spikes, swells? Those things all make a difference accordingly. So I'll tie in with the tuner, verify what's been happening over the course of the history of the unit. Once I'm done with that, I'll go ahead and I'll put it into a wraparound bypass. So I'll shut down everything. I'll pull covers, verify torques, make sure everything looks good. Then I'll go ahead, after I'm done with the mechanical and electrical inspection, bring it back online. A battery maintenance is a secondary service, which yearly what we would do is we would come with a fluke meter and we'd actually check resistance, temperature, and voltages on all the batteries. Okay? When we do that, then as we go year after year, I can see the reports from the last technician and the last technician from mine, and then everyone can see the information accordingly. So if cell 5 is starting to see high resistance and low voltage, then we can start trending that, hey, maybe we need to replace the battery, right? Battery should be under warranty, I think, I want to say like 2 years, I want to say. It could be 3, but I think it's 2.
Prorated or is it just 1-for-1?
What's that?
Is it prorated or is it?
1 for 1.
Okay.
Yes, sir. Yes, sir. So at that point, if, say tomorrow, you guys start having battery alarms, we come in, we stack the batteries, we'll call in, we'll have battery shipped, we'll come back, we'll install it, be done with it. If it becomes a big deal, so I have a site where temperature became a factor. They were hitting 130 in a little bit of time. Well, they went to a low DC. Low DC sagged off low enough to where the batteries were no longer good. So with that, because of negligence, it became the customer had to purchase batteries. If the customer had called us in the very front end when they saw they were having the issues, we could have prevented that, right? So that's kind of where there's a line that they'll look at it and they'll judge accordingly. The system, if you guys do have a network that you guys want to set up subnet IP and a gateway for, and you guys want to tie into this network management part, you can remotely look at everything within the system. And it's very user friendly. You can set up email notifications for who's on call. You can set up a little bit of anything and everything. And instead of having to come down to the basement to check on it, although every now and then a round wouldn't be bad, but if you can see physically, I'm online, I have this much percentage load, my last time I transferred to bypass or off was because of this, all of that's readily available.
Can you control it from your computer? Or?
There are means and methods that you could possibly put it into bypass, but it's things that you really have to have access, right? And it's normally a noded access. So even with the display, we can program anyone that you want to have a single passcode. So then you know who walked up to the unit, who turned off the unit, who did anything accordingly. That's also a possibility. But yes, you can do certain little things, but normally nothing that's going to really affect the unit, right? That's the main thing is the unit wants to be online. It's going to scream if it's not online. It wants to be there. It's going to do everything it can to be online.
Is there a program we need to download?
No, that's the best part. Once you have the subnet, IP, and gateway, it's all derived from the physical UPS.
Does it have a
We
back
tied
net
into our LAN rack here.
Backnet's in there?
Yeah. Yeah. You can do anything. IPv4, IPv6.
Most of it's backnet to hit the world lead, so that's why.
Yeah. You can do any means and methods to communicate with it. Once you have that set up, I'll tell you it's an amazing program. I've had customers that had the early inceptions, and then they got the newer inceptions, and they were like, "Where has this been my whole life?" So it's a good way any one of you guys can check in on it and feel comfortable. Okay. With that main controller all the way across here, right? That's going to basically be your network management part, your intelligence module, all of your main controllers and everything are within this section. You have power module here. This is basically your inverter, your rectifier, your DC charger. It's everything all in this guy here. You have your static switch, which is basically to transfer between utility and UPS back and forth, just a solid state switch. Okay. Down on the bottom is your inputs and outputs, battery terminations from the maintenance bypass cabinet. This is IMB. IMB, we put a zip tie in there, and it's not supposed to ever be used. Once you add in the bypass cabinet, IMB is not an issue. It's no longer going to be utilized. DC, it's kind of hard to see, but you just have a single DC breaker here. You have some schematics, and you have all of your nameplates. So that way, if you need any information, what type of batteries in there, anything, you'll just be right on the front door. Very easy to see. Also, you'll have instruction manuals and anything that'll give you an idea of how it's wired and what needs to be wired if anything changes. So, on the back of the UPS door, there should be whatever manuals that we have, they're going to go back in here, and you'll have those there. That's normally where we'll put them. You guys may change that, but one of our questions on preventive maintenance is are the instruction manuals there? So if you guys have them, we will note that no, they're not. Okay.
How many batteries does it take?
So this has 40 batteries, 40 12-volt batteries, which is basically your six cells per battery, and normally 2.4 volts per cell is what we charge them at. So you're talking about 560 volts in DC.
So they're series wired.
Yes, sir, that is
So
correct.
if we had a battery go kaput, like you were saying.
Yes.
And we had to wait right now, 6 months or better for a battery, will this system be down or will it just be less, just a little bit less used?
So there is a possibility that we could short string it, okay? Adjust the DC voltages to get you by, okay? It's all gonna take our engineers' approvals to make sure that everyone's aware what's happening, right? If we short string this, we don't wanna leave it for long. We lean on our manufacturers that we get stuff from pretty hard, so you might run into a couple issues, but most of the time,
There's in Canada to move aside so we can get our batteries, right?
yes, yes. So that's going to be, it can be done. It's just going to take a little bit of approvals, and it's going to take everyone being on the same page. So that way, I walk up to the unit, I know what I'm walking into, and then we get a new
That's if
battery.
we use y'all, whether it's under warranty, right?
Correct.
But if it's, say, like it's out of warranty, and you guys are gonna check all that on the first year.
Yes.
Manual, the batteries, the system, the works.
Yes.
And then after that, we're on our own unless we get y'all service.
That is correct, yes, sir.
Okay, and then the batteries would be a separate part of that as well.
That is correct, yes, sir.
Okay, now, if, let's say, we don't have your battery service,
Uh-huh.
and one of the batteries goes down, are we able to adjust that down, or do we have to still call y'all to adjust it down if we're waiting on a battery?
So Snyder tries to make everything proprietary. That's the honest thought process. So what ends up happening a lot of times is if we have a third-party vendor, the third-party vendor is hoping that our equipment never has a problem. 90% of the time it doesn't, and so that's perfect, right? The times when it does, that vendor has to pay us to come out to identify, fix, and repair, right? which means they're gonna get charged. Hopefully the vendor's a good vendor and they just absorb the charge, they don't try to pass it on. But in reality, we always try to keep everything proprietary. That's just the nature of the beast, you know? So, there might be some settings where you might be able to lower the DC voltages. You do have configuration access, but you don't have tuner access. So, if, say, I adjust just the DC voltage enough to get me by, right? Possible. But at the same time, my analytics are shot. So you might see 5 minutes of runtime, you might have 1. So that's where you kind of get into, I can fine tune that to represent your true runtime calculations. That's why the proprietary comes in.
That's a technical thing that, we shouldn't be touching.
In reality, yes. I'll tell you, a lot of vendors will be able to support the system 90% of the time. Okay? That's the reality of it. There's going to possibly be those few times where it hurts the pocketbook and then people realize the change, right? That's for us, a module coming up with a good amount of money on the drop of a hat sometimes is way more detrimental than saying, we've already allocated for everything. If anything happens, we don't have to think about it, right? That's the peace of mind that comes in.
So for this service plan after the first year,
Yes.
we can wait and purchase that after or at the end?
Yeah,
of the
yeah.
year?
So you can purchase it at the end of the time. You can
Is it
even.
annual or is it? for-
It is annual, yes, sir. Now, that's the thing, you can purchase it at any time, okay? The one thing that's gonna take place is, say you get through the manufacturer's warranty, you wait 5 years, and then you decide you wanna put it under contract. We just have to come out and inspect it.
Make sure it's not kaput before you.
Yeah, exactly, before we
You
assume
don't distribute,
responsibility.
yeah.
Yes, sir. And so we'll just do what's called a recert PM, and we'll get you back under contract. So it's kind of a no harm, no foul thing. It is what it is. Like, budgets and money is important, right? So you do the best for what you believe is the situation. So with that, system is phenomenal. Display, if you guys have to do anything to the unit, the display will get you through everything. So if we come back to home, we went through, we got into the 3 bars. If you notice, you have a couple icons that are locked. Those are where you can do the damage, right? You change modes of operation, you can do configuration changes, you can do a little bit of anything, okay? When you get to the about, so let's say everything's working fine, you guys have an alarm, you guys want to call into Snyder Electric. You hit the about, you have a QR code that you can scan in, which will give you numbers or whatever you may need. I'm going to leave a business card that's going to have the 800 number that will be what you'll utilize to call tech support. They're going to ask you for the serial number of the UPS. That's right here. You just literally, you come back to home, first thing you do, hit the 3 bars, about, that's going to bring up your serial number and anything that you guys need, okay? Once you get that and you get the call in, they may have you do some troubleshooting. They may have you look at some of the logs, look at the history, and explain to them what you're seeing, okay? Tech support does a really good job. They're good at identifying issues and then having the equipment here by the time we get here. Most of the time, unless it's high dollar parts, they'll have us come check it first. We'll order the parts, get them overnighted. A lot of times we do overnight. We can do same day, all depending if you guys are carrying contract, right? So that's always big.
How much are batteries?
Batteries, they keep us out of pricing.
Okay.
You know, because a lot of times government has to go through another agency to spend money, right? Other people use a wholesaler for this, and so if I interject any pricing, I don't know who's involved and what the chains are, so they keep us out of pricing. It's every 5 years. I'm guessing I would look at anywhere. Hard to say, but I would say 3 to 10,000 maybe. I would keep kind of just as general, but you can get an idea by talking to whoever the provider was that sold it. I think Connor and Swimco. got you guys taken care of. Swimco, they're a great company. They do a good job. They will take care of you. They'll let you know anything. They'll get you pricing if you want to know. They'll tell you exactly where things sit. So it's kind of top one.
If you have any updates, can you push them wireless?
No. So everything network. Oh, everything's going to be network. Just because of cybersecurity, everyone wants a hard line. We try to stay away from anything wireless that could create an issue. What we do is when we come in and we do our startups or we do our preventative maintenances, we push firmware at that time. So that's the other side of having third party do your maintenances. They don't and can't do firmware. So there are things that maybe when we built this unit, we had a contactor that we had to time at a certain time frame, right? And we put firmware to adjust for that. Well, we decided that, okay, we can actually transfer that faster, which makes it work and function better. Okay, we're gonna write that into the firmware. So it's gonna acquire faster, it's gonna do what it needs to do better. That's the main reason about the firmware. Sometimes when this unit came out way in the very beginning, there was an issue that would basically allow a self-test if it didn't have enough capacity, like say we're 1% loaded, right? And it goes to do a self-test on battery. Well, self-test on battery doesn't have any way and it doesn't see enough of an inrush to say, hey, we're discharging, and it created an issue. Firmware came out that fixed all of that. So some of our customers that haven't had contract for a while call us. Our batteries are dead. Correct, they are dead. You know, I wish I could do something for you, but I could put in new firmware that'll take care of that issue from here out, right? And so it's fine line. You know, we do the firmware. Anyone else cannot do firmware. Okay. We've gone into a couple things. I want to show you guys the biggest things that really you can get into. Okay, control. We want to do something with this UPS, right? Username is admin, but it's lowercase, so turn caps off. ADMIN, enter. Password, also admin. You guys can adjust and change this accordingly. You can also give individuals their own password. Okay. So at this point, I want to control the UPS. I can do single things like change the operation. I can take it from regular inverter to static bypass. I can turn the inverter on. I can take the charger and turn the charger on and off. Normally not things that normally are done. The main ones are the guided sequences. So with the guided sequences, they give you a couple options, right? Normally the two options you're going to get is start it up or shut it down, okay? And that's going to leave you in a maintenance bypass state. So if we go to shut down the UPS, okay, it's going to give us a whole list of items to do, okay? I'm a firm believer that if I could say step 5A failed, I'm not liable, right? Anytime I can say where step failed, it's not my fault. I followed along. So I always say guided sequences is the best way. Turn it on, turn it off, and do anything you want. So we're going to basically transfer to static bypass. You see we have the hotkey. Gives me a check mark after I've taken care of that step. Next step, it's asking me to close the breaker with MBB. Okay? So with MBB, if you notice, my green light came on for MBB. That's my okay to operate. As long as that's operatable, I can come here, I can close it. You see my other light, UOB came on. It came on because I'm overlapping utility output from the UPS and utility from the physical input utility. Both of those are overlapped right now. Breaker's closed, breaker's closed. You look at the single line, this breaker here is closed, this breaker here is closed. I'm feeding two sources out to your panel right now. It's the same source, it's all utility source, okay? We're gonna go ahead and open up UOB. The system's smart enough to know that I can either open either one of these, but I'm still gonna provide power. So now following the steps, tell me to open up UOB. Now, my MBB light, it doesn't want me to operate again. Okay? UOB, everything shut off, so it's telling me that I'm at the correct stage where I'm at. We're gonna turn the inverter off. You should get the UOB to open again because it doesn't want to take those two sources together. That's just a means and methods for how it works. Opening up battery breakers. Come over here. We have our DC. We open up the DC and open up UIB. So that's our unit input. So at this point, we're feeding your guys' load with utility power. Okay? UPS is off. We could lock everything out. We could remove the UPS and put a new one in place if that's what it took at this point. Okay? Completely isolated, completely safe. We walk up to the unit. Yes, sir?
Is that the program that we can get? Because you can see the
No.
graphics when you're doing
No,
that,
you
right?
can't see any of that. But I'll show you where you can find those graphics, and you can go between a couple of different menus to see as you're doing the shutdown or startup, you can see that single line. But that single line for us is that's our tuner. Okay? So if you shut it down correctly, it's always going to want to be in maintenance bypass, right? Okay? Which means you're supplying your load currently. If say I walk up and I turn everything off and I open up my maintenance bypass breaker, I've killed the load. If I close my input to the UPS, it's not going to give me the correct statuses to do a startup following the guide. It always wants to be in a maintenance bypass state, right? If I'm off. So say I shut down, everything's open, load's off, everything's off. First thing I would do when I walk up to the system is I would close my maintenance bypass, which is going to take utility and feed it out to your load.
And do we have all these step-by-step instructions on paper?
So in the instruction manuals, it does go through startup, shutdown. It goes through all the modes of operations. Tells you how to get from point A to point Z all the way through. So yes, the manuals will be very
The manual
helpful.
will be on that door, right?
They will be on the inside of the door. Yes, sir. Yes, sir. So at this point, we know we're in maintenance bypass. So next step is going to be close our unit input breaker, which is going to start up the logic to the UPS. Take about 1 to 2 minutes for the logic to come up to where after it does all of its self-tests, does everything that it needs to do, it'll come up. And then we'll go into the guided sequences, but I'll also show you where that single line is so you can physically see all the steps and stages.
What does UPS stand for?
Uninterruptible power supply.
If something happens to one of the batteries, is it having no battery output? Is this the only way to
It does, it transfers the static. Yes, sir. Anytime you have a total discharge, or anytime the battery breaker is open and it can't support, it will go accordingly. Yes, sir.
We wouldn't know that unless we come down here and look at the unit or we have that program.
That is correct, yes, sir. Okay, so now we talked about UPS mode, we talked about maintenance bypass, system mode. This is basically giving you an idea of the different statuses you'll see. Before we were all green, we were on inverter. and system mode was online. So you'll be able to see system mode's off, we're a maintenance bypass. It's annoying, and it's meant to be annoying. You're in a fault state, right? System's not online and it knows it. It's not happy. We talked about this being either a green check mark, amber or yellow exclamation, or a red foam. Right now, we touch it and you can see we have informational warnings, we have critical faults, and we have a few pages of them. All of these faults that we are seeing are all expected faults because of the mode of operation that the system's in. So nothing to worry about on the startup. Okay. So we talked about single line. Right now, we touch the 3 boxes. It'll bring up your single line. And this is giving you the flow of power. Okay. You can see that we closed the unit input breaker. We know that the maintenance bypass breaker is closed. We know that the output breaker is open.
Mm-hmm.
And we know that we're feeding utility power around the UPS at this point.
How did you get there again? One more time, sorry.
Oh, yeah. So you'll walk up, you'll be on the home screen, and then it's just this representation, 3 boxes.
Okay.
It's the representation of a single line. Once you touch that, that'll bring up your single line, and it'll give you the status that the system's in. Okay. Now, what we can do is we want to do the startup. We talked about, we shut it down, it's time to start it back up. So we come in, we go to control, we type in our passwords, username and passwords, lowercase admin, password, lowercase admin. Once you log in, you have those locks have cleared, so now you can control the unit. We want to go through guided sequences, and at this point, we want to start it up. So the system's going to check and see what we need to do next. Okay? Close battery breakers, right? So we're going to come over here. We're going to close DC. We got battery breakers closed. Now, if you want, we can abort this at any time. We can come back and see our single line. So DC breakers are closed now. We're charging the batteries. Batteries are black. They are red if they're in a fault or not attached or something's going on. Once they're black, they're good. If they're green, they are possibly outputting because there's no input. Okay. So we go back to where we were. We go back into control and we pick up where we left off, guided sequences. We're still starting the system up. Okay. So at this point, we want to transfer to static bypass. Okay. So what that's doing, we hit transfer. It's turned on my static switch. That's taking utility power in and putting utility power out. We can abort. We can go into our single line. We can physically see. Now all of a sudden we fired our static switch, which means that we're taking utility all the way around and we're taking utility up to the front side of this breaker. So when we close this breaker, we're putting both utility sources together. Okay? So it's all make before break. Completely opposite of any electrical thought process that you would normally have. Always take away power before you add power. This takes the same source of power and combines it together. Okay? So we're going to go back home. We're going to go ahead, I like that one. Control, guided sequences. We're going to continue our startup. Now notice how the green shutdown came up. If say we decided we wanted to go back and we want to turn it off real quick, it does give you that guidance that you can go backwards. So we're still starting up. So we're going to close breaker UOB. Should have a light, breaker UOB, it's okay to close. Okay. We're going to come over, close our UOB. Notice that we have both breakers closed. We can go either direction now. We can continue to start up, or we can shut it back down following the guided sequences, which is why either one of those are illuminated. Both breakers off at the same time means those lights. Okay? So it's always telling you it's safe to operate one at that point. It's asking us now to open up MBB. So that's our center breaker here. Opening that up, and it's cleared us. So now we know nothing, we don't need to touch anything. UPS is auto starts on. So once it auto starts, it completes it. You can either press complete, sometimes abort works best, and then you can come back over to your single line. And if you notice, I should have showed you before I closed my, or before I opened my MBB, but when I closed my UOB, we had power flowing through here, and we had power flowing through here. Once I opened my MBB, it auto started, which brought the system onto full online. Okay. So it's all there, it's all representative. You can stop at any point. You can go back and look at the display and see where you sit. You could go any direction you want. We have exclamation point, which is basically the load, which we need to balance the panel. So normally you'll walk up and that'll be a green check mark. There'll be nothing now. We'll get that taken care of once everyone is done with the rundown. Systems really does amazing things. Anytime there's a sag, a swell, or any change to the status of the unit, my tuner will give me waveforms, 15 seconds in front, 15 seconds in back. So I always tell everyone, if you don't know, be ambiguous, it's okay. Once you start saying, oh, this happened and it didn't happen, we'll know. Breaker opened, we know it, we can see it. So that's always the easiest. Be ambiguous if you're not sure. Read what you see, and that makes life so much simpler, you know. I think that's the best route you can always go with these units. They're very intelligent, they can see everything and know everything. Also, if you guys have an issue with power quality, something happens, we can pull those logs and you guys can utilize those logs for maybe the power company to say, hey guys, you're sending us bad power all this time, and we can see it. So there's a lot of interface that we have with that. Beyond that, we've done a shutdown, we've started up, we've talked a little bit about the ways to get through the UPS, how to operate it, what to see on the displays, passcodes. Is there any kind of questions or?
How can you assign different passwords?
So that will be all within the instruction manual, and it'll be in the operation guidelines. And you basically, it's a thick book, right? So there's all sorts of different things that you can do with the system, and it'll explain it all through that process.
If the battery goes down, will it say which battery it is? That's what.
No. So the way that this is set up is it doesn't have any type of battery monitoring service or options at this point, right? Normally,
on the main screen if there's a fault, right?
Yes. So with that, you're going to see DC, low DC. You'll see DC breaker open. It'll give you a lot of analytics, but it's looking at total string, it's looking at physical breaker, and it's looking at physical temperature. Okay? So with the maintenances, that's what you would find. Because without a battery monitoring service or a company like VTech, Albert, or anything that's a separate entity, right? It's just total string, nothing monitored individually.
So if we use your service, we don't have to worry about pocketing out the money for the batteries, or?
You don't have to worry about what?
We'll probably look at
There's two services,
Okay.
and one of the service covers the battery. The other service carries the technical portion.
So
So,
we're covered under the service warranty for the first year, and the batteries are warranty for two.
I want to say two.
2 years, 2 to 3.
I would have to look into that, but yes, 2 to 3 years.
Two, right.
I think about 2 years.
so ultimately, we have to have two service agreements in order to really be 100% covered.
No, I would say, so the service contract and agreement is going to take care of the system, right?
Right?
Okay. Anything happens, whether it be like your DC breaker's having an issue, that's all covered, okay? The preventative maintenance is what's giving you insight into how those batteries are working. So that's just a separate service on its own, right? We want you to come do a PM. PM, we're going to look at this. We're going to take a look at the batteries. Well, we aren't going to stab them. We're not going to get voltages. We're not going to do any of those extra acquisitions. That would be the secondary part of service. But anything happens, the batteries are warranted. We come in, we find that we have battery alarm, okay? We start looking at the batteries. At that point, because we're maintaining the unit, we're gonna stab the batteries to start seeing, why are we failing? What's going on? What's happening with these batteries? High resistance, or what's the problem, okay? At that point, I'm gonna get on the phone and I'm gonna call into my tech support. Tech support, if the batteries are under contract and it's a failed battery, tech support's gonna order the new battery, set up another maintenance service or a warranty, it's a warranty repair service. They're gonna get someone back here as soon as the battery lands. Okay, and that's another thing. So let's say you guys aren't carrying contract, right? We have other customers that are carrying contract. You break, you have to get in line at the end of the line, I guess, right? Not hey, we got a 4-hour, or we have an 8-hour, or we're your paying customer, we need you today. You know what I mean?
Right.
They can put you at the very back of the line. Chances are they won't, because we understand the situation, right? We don't want you to wait any longer than you have to. But if everyone's busy, and they're not going to adjust anything.
Right.
You know, PMs, which is basically me coming to check your unit, takes more precedence than your broken unit at that point. Bad point to be in at that point. If you're under contract, they'll move my PM to make sure that you get your service. Okay. So that's the point. Any other thoughts, questions?
Floods are common around here,
Okay.
so we got insurance on this thing, or?
Insurance, building insurance should cover most of the time. It's act of God, right? Or what could be considered as building insurance underlying, right? So if, say, the unit gets swamped and you have water issue, okay? At that point, it'll be a claim with your insurance company, but we'll come out, we'll look at it, we'll identify the situation, and then we'll write up a report, and you guys will be able to take that report and submit it to insurance. That's kind of how that would normally work. You guys would call it a break fix, essentially. At that point, then wherever it falls at that point is what's going on.
So if you got an emergency and that pipe breaks, shutting the breaker down, or you still got to kind of go through that menu?
So, major issues, okay? Major issues. If you can get to the DC, open DC, okay? Come over here, open, keep on running. It doesn't matter, because who cares if the lights are on at that point, right? It's more a catastrophic situation. Shut it off, keep on running, do what you gotta do. No screen necessary. Main thing, opening up the DC. If you open up everything else, DC is gonna run until it dies, right? Well, once you take off all the load, there's 0% load, which means batteries have a ton of runtime now, you know? So, if you can hit DC, shut everything off on the way out. If you can't get to DC, it's gonna run, which means fire department's not gonna be so happy they hose it down, you know? Now, there are options if you guys decided you wanted a remote shutdown. We do offer those. That is an option if you guys wanted to have an EPO switch somewhere, anywhere. But that would take more wiring in here, and then the installation of the switch. But those are options. That would immediately trip the input breaker. It would immediately trip this breaker and make sure your bypass is open. It should already be open in normal operation. Yeah. If anything does happen where the DC does see that there's a problem, get to a low DC point, it'll trip open the breaker on its own. Okay. So that's one thing that we should talk about. You guys walk up to the system and battery breaker's open and logic's on, but the unit's not supplying the load. It means that you probably had a long duration outage, right? Battery's got to a low DC, it tripped open the breaker. After it tripped over the breaker, your input power came back on, okay? Which a lot of times the static switch will fire and supply the load, but it'll be in a bypass state, not battery backed up. Okay, so then at that point, you would basically just go through the process, look at the system, see where you're at, and then reboot it. If it's under warranty, by all means, you can call us, we'll come out, or under contract, we'll come out and we'll identify what happened. That way, if you need logs or you need information, we can get it. If not, you can follow the manuals, it'll get you through there. My business card will be right here. It has my personal cell phone, so whether I'm with Snyder or not, I hope to retire from here. But it has my personal cell phone, has my company cell phone, and it also has the 800 number to call in the event of an issue or emergency. So I'll leave that on the UPS. Really, that's just about everything. It's a good system. I've seen them 150% overloaded. I've seen people try to break them, and commissioning agents have a hard time breaking them. So I'm happy with that. You know.
Where's this unit? A lot.
See if we get a discount. Yeah, you did on it.
Woo! I will note all of those damages. I can note those on the report.
There you go. No, I'm just kidding.
How long does it take to fully charge the batteries?
You're looking at, I would give it 72 hours, but in all reality, you should be looking at an 80 to 90% charge by tonight, close to 100% by tomorrow morning, and then I would figure they have enough time to desulfate and do everything they need by 72.
So this is strictly just for lights, just to keep the lights on.
As far as I'm aware, yes.
So if it's for refrigerators or whatnot,
It won't like it. It'll scream, and it'll let you know it's a bad situation. Resistive loads it doesn't like, motor loads it doesn't like. So a fridge has compressor, it's got a big motor load, it will not like it.
A big Motel 6, where they keep the lights on.
Any other questions or thoughts or?
I think that's about it.
Okay.
I appreciate it.
Hey, no problem, no problem. My information's there. If you guys just walk up to it and you just aren't sure, don't hesitate to reach out. I got a few minutes. We'll talk about it. If it's something major, I'll tell you to call tech support. If it's something we can walk through, we'll walk through and get it going.
Okay.
And the program that you said that we can get on our computer.
Yes. So the program is actually derived from the network management. So if you have a server that you can get a subnet IP and gateway, you can program subnet IP and gateway into the display, and then you can go to your remote, get it onto it, and you can see everything. It's all already derived. Your password and passcode, login and passcode is APC. Once you do that, it'll bring up the whole browser, everything will be there, and like I said, it's a very nice situation. It's similar to what I have here, but not as in-depth. You know, I have a lot more things that I can do than what you guys would have. But yours is more on an administrative side, right? It's to set up your network settings. It's to set up your people that you have working, to set up addresses. If you want to be email notified, who's going to get the notifications? And then if you just want to look at the status of the unit, it's all there.
So let's say that we're getting a warning that's overheating.
Yep.
What do we do then? We just open the doors or?
So overheating, 104 degrees, I believe, is your limit, but it can go over that. It will give you a overtemp alarm. Once you get over a certain overtemp, it'll derate it to 75% of the total capacity. Once it gets to a certain point, it will force the static switch on and isolate everything else so it'll protect itself. So in all reality, the biggest thing you need to do is call the 800 number, tell them the serial number, let them know what's going on, and they'll run you through anything and everything. But in all reality, you shouldn't be getting over 104 anyways. If you are, your batteries, every degree over 72 degrees, you will cut 10% off the life of your batteries. So if you're getting in the 80s, the 90s, you're getting into the hundreds, you're already taking your 5-year batteries down to 3 years. That's the nature of batteries. You know, they will give you a longer run time the warmer the room is, but their life duration shortens. If the room's super cold, the actual run time will be shorter, but the life of the batteries will be longer. So you want to try to stay right in that 72 degrees. That gives it the ultimate life of the battery, the ultimate charge and discharge of the batteries. That's what the manufacturer is asking for us to do when we're charging their batteries or maintaining their batteries. So you really, if you see that you guys are starting to get into, I would say the 90s, the unit starts to derate, okay? 95 is an alarm for battery temp. And then the closer you get into the 104, 105, you'll start having modules where your heat sinks will over temp, you know, stuff along those lines. And when they over temp, what it'll do is it'll shut the module off until the module comes back into spec. Once it comes back into spec, it'll turn it back on. Then it'll probably overheat again. It'll shut itself off, come back on, and on the third time, it'll shut itself off indefinitely until the system's rebooted or restarted.
So let's say that we wanted to have this system shut off for 6 months.
6 months.
Would
Okay.
that damage the batteries system? Would that?
6 months you say is perfect time because 6 months is the minimum time or the maximum time a battery can go without being charged before the manufacturer, whether it be Enersys or whoever is the battery manufacturer, will say that it's out of spec. So if you were to start it up in 6 months, turn it off, start it up in 6 months, charge it, get the batteries fully charged, turn it back off the next day or the next 3 days, you could technically meet that need of that 6 month recharge. Then you could shut it off for another year if you needed to. But the main thing is that you shut the unit off. You make sure that the batteries are disconnected.
Batteries are disconnected.
Yeah, that'll be the battery disconnect here.
Just that?
So it just need to be open.
Okay.
Yeah, once it's open, all the batteries will be in a series, everything will still be connected. The battery breaker is split string, so you have 2 rows that are one side of the breaker, you have 2 rows that are the other half of the breaker, and then you have the 2 feeders that are the charging. Okay.
So by doing that, do you think is that we can extend the life of the battery, the life of, you know, anything breaking down, or not necessarily?
It's hit or miss. So a stagnant piece of equipment, you have capacitor life. Batteries are a capacitor. So no matter how you look at it, even if you're shutting it down and leaving it off, you still have the capacitors, the oils, the things inside of it. The longer you leave the batteries uncharged or not charging, sulfates build onto the plates, and then it makes it harder for the charge to get into it. So it's it really wouldn't change anything. You know, if my power modules aren't running, they have capacitors inside of them, the oils aren't doing what they need to do, everything's not actually functioning. So it's just like taking my truck and putting it outside and not starting it and saying I'm saving it.
Right.
You know what I mean? Over time, moisture's going to build up inside the block. There's other things that are going to happen, and then when I go to start it, my battery's not going to start, right? Then I got to jump it and do those other things to bring it back to life. Same kind of thought process. You really never prolong anything by not utilizing it. You know, it's one of those things. You
But
know,
the main thing that we want with this unit is that when we lose power, we still have emergency lighting for evacuating the building or whatever else is powering up. So that's the main thing. So we would never want to turn it off to say, hey, we're going to extend the life of the battery. We want to have it there and ready to be used at any moment.
And you said that this is just for the lighting?
that is correct.
The emergency.
So thank you very much.
Hey, not a problem.
Appreciate it.
Pleasure.
Thank you.
Pleasure. Yes.
Good.
My information will be up there, so if you ever need anything.
All right.
Yeah. Thank you. I appreciate your time.
Thank you.
Thank you. Thank you. Forward all that?
I did, and I'm actually gonna type it up in an email and send it to you and Brandon.
Okay, sounds good.
At least the high points.
Right, okay.